you're all safe and doing well, and looking forward to seeing you on the Zoom class meeting this week, as well as the optional meetings, which are open to all of my Algebra I students on Wednesdays and Fridays at 2 o'clock. So please join me for those meetings. If you can't make those particular times, please email me and just let me know that you're doing all right, and I would really appreciate that. So today we're going to get into a new topic, an extension of what we learned last week. The homework for this week will be both a review of last week and then what we're doing this week, which is adding and subtracting radicals. Okay, so I'm going to do some notes here for about 10 minutes, but I wanted you to know that I've also taken these notes and put them on Schoology for you so you can print them out and look at them while you're doing the homework as well. But it's really going to help you if you watch this short video just to get the steps, okay? So adding and subtracting radicals, it's basically like adding like terms. If you had something like 3x plus 4y plus 7x minus 2y, then you would know to add like terms and combine the x's with the x's and the y's with the y's. Well, adding radicals is very similar to that because we can only add radicals that are exactly the same. Like a radical 2 plus a radical 2, you could combine those two exactly as we do with like terms. The same with the radical 3 and radical 3. But a radical 2 and a radical 3, right, the square root of 2, the square root of 3, same idea. Those two are different values. All right, just like an x and a y are different values for variables. They might be the same, but a radical 2 and a radical 3, check it out on the calculator, are never ever going to be the same. So if you had something like, let me just kind of extend this, if you had 3 radical 5 plus 4 radical 2 plus 7 radical 5 minus 2 radical 2, right? You can see that kind of use the same coefficients there. You're going to combine the radicals that are exactly the same. So the radical 5's, 3 plus 7 is 10, so 10 square roots of 5. And 4 minus 2 is 2 square roots of 2. And this is where you would need to stop because, again, square root of 5 is different from the square root of 2, so you couldn't combine those anymore. Now, these are problems where the radicals are already simplified. We don't have to break them down. Not all problems are going to be like that. But let's just go through a few first before we work our way up to the more complex ones. All right. Let's say I wanted to simplify the square root of 6 minus 4 square roots of 6. So even though we don't have a coefficient here, just like with an x or a y, we can think of that as 1 square roots of 6. So 1 minus 4 is negative 3. This would be negative 3 square roots of 6. Let's say we had 2 square roots of 10 plus 7 square roots of 10 plus a radical 3. Well, I have 2 radicals that are alike, one that is not, so I can combine these and say that 2 plus 7 is 9 square roots of 10, but the square root of 3 just kind of comes along for the ride. You carry that down, just as you would if you had an x plus a constant, right? You would combine the x's and bring down the constant, okay? So that would be it. Now, we know that they're not all going to be as quick as that. So here's when you need to do some simplifying first. Okay. So if I had the square root of 8 minus the square root of 2. Okay. Don't say square root of 6. All right? That's not the same. Okay. Check it out on your calculator. Do the square root of 8 minus the square root of 2. You're going to get a decimal minus a decimal. And then do the square root of 6, it's not going to be the same value, okay? So the square root of 8, you would need to break that down like we did in the last section. Right, you make your tree, you circle the pairs, put a square around the leftover. Simplify the square root of 8 is for every pair you take out 1, 2 square roots of 2 minus square root of 2 is already simplified. It has no perfect squares in it. If I didn't know that, I'd try to make a tree, but we can't really do that for 2. So now we get to something where sometimes we can keep going, and sometimes this would be the last thing, but square roots of 2 are like radicals, so we can combine them. Think of this as a 1 square root of 2, so 2 minus 1 is 1. 1 square roots of 2, or just the square root of 2. Alright, this is just like a 1x, it's the same as an x. Okay, so sometimes in problems you have to simplify first before combining. Sometimes you might have both of them that you need to simplify. Sometimes there might be several radicals. Okay, let's try 2 square roots of 5 plus 3 square roots of 75. So again, if I'm trying to combine them, I don't know if it's possible until I simplify them, okay? So 2 square roots of 5, again, this one's already done, just like the last one had a square root of 2. But the 75, I know I can break that down, see what factors are in there. It ends in a 5, so I always divide by 5 if it ends in a 5. 5 goes in how many times? I think it's 15 times. And 15 is 5 times 3. So I do have a pair, right? I've got 5 and a leftover 3. So for every pair I take out 1 and put the 3 back in. Now here's where people start like losing part of the problem. This is just the square root of 75. So now I need to put this right back where that was. So I did have a 3 on the outside. Just carrying everything down for organization's sake here. So this is 5 root 3, right? The square root of 75 is 5 root 3. Now the 3 and the 5, I can multiply outsides with outsides. That's from the last section. And after all that work, I don't even have like radicals. And so this is really all I can do. I can't make it one term, okay? All right, so just one more, and I'm gonna make it a good one. Last example, square root of 50 plus the square root of 18 minus the square root of 75 plus the square root of 27. So I have 4 radicals. Once again, I don't know if I can simplify them. I'm sorry, if I can combine all of them into one or not. I have to break it down into the factor trees. That's how I do it, okay? So 50, 2 and 25, 5 and 5. Pair of 5s, 1, 2 left over. Every pair, take out 1. Put the leftovers back in the radical. 18, 2 times 9. 9 is 3 times 3. Pair of 3s, leftover 2. So for every pair, take out 1, put the leftovers back inside. It was a plus in front of it. 75, well, I just did that one in the last problem, right? But set it up again. 3 and 25. 5 and 5. Pair of 5s, leftover 3. So it's a minus 5 square roots of 3. 27, 3 and 9, 3 and 3. Pair of 3s, leftover 3. Every pair, take out 1, put the leftovers back in the radical. And it was a plus. Now that I've done that, I see that I have some square root of 2s and a couple square root of 3s. And so those are the radicals that I would combine. Radical 2, so that's going to be 8 square roots of 2. Careful with the signs. -5 plus 3 is -2, so -2 square roots of 3. And that would be the answer. All right, well, try your best on the worksheets. I've got 2 worksheets. Please do all of them on the sheets. Please write it on a separate piece of paper. Okay, this is the work for the week. If you have any trouble, please let me know. If you have any questions, come see me in a Zoom meeting as an option. But I'll see everyone in class this week. All right, take care and have a great day, folks.